This is Dr. K. Venkatramana, Department of Mathematics, Vardhaman College of Engineering, Assistant Professor. Now we are going with the topic of Rolle's theorem, which is one of the topic of matrices and calculus. Now we are discussing about the Rolle's theorem topic. Now Rolle's theorem. What is the statement of the Rolle's theorem? Rolle's theorem statement is let f from closed interval a comma b to r. This is the interval closed interval a comma b to r be such that this should be a continuous function in closed interval a comma b, and this should be differentiable in open interval a comma b. Third point, f of a is equal f of b, then there exists at least one c belongs to open interval a comma b such that f dash of c is equal 0. This is the statement. This function f should satisfy these three conditions. Then there is an element c existing in between the interval a comma b, and the derivative at that point becomes as 0. This is the statement of Rolle's theorem. Now I am giving the description of the Rolle's theorem. How to listen? Here this is our graph a b interval. In this interval we define a function f. So for example, here this is starting. This is our function existing here like this. Here it is starting. This point is a comma f of a. This point is b comma f of b. In between these 2 points, this function existing, that means the values of the function is existing in between these 2 points interval, in between the interval, and the derivative is existing at each and every point. So these are all different points on this interval, on this limit, on this curve. At each and every point the derivative is existing, then it is known as differentiable. Derivative existing means there is a tangent is existing. So because of that, the derivative is nothing but slope. So this is our second condition. First condition is function values are existing in between this interval. Second condition, the slope of the point is existing at each and every point. Third condition, the value of f of a, this one, the value of f of b, that means this one. These two should be same, f of a and f of b, these two same. Then there existing at least one c, in between these two there existing one value c, such that the derivative at this point is 0. Derivative 0 means that tangent is parallel to x-axis. So at this point we are getting a tangent. This tangent is parallel to x-axis. So here one point existing means we are saying that there existing one point, at that point the tangent is parallel to x-axis. That one says about the Rolle's theorem. Now we are going with one example. Now verify Rolle's theorem for f of x is equal x minus a whole power m into x minus b whole power n in closed interval a comma b. First we need to say that this one continuous, second one differentiable, third one f of a is equal to f of b. If these three conditions are satisfied, then only the Rolle's theorem is applicable. Now first take that function, given one f of x is equal x minus a whole power m into x minus b whole power n. If you are observing this one, it is a polynomial function. We know that polynomial values are existing at each and every point, and that's why it is a continuous function. So first point, f of x is continuous in closed interval a comma b. Now coming to the second condition. What is the second condition? F is differentiable, which is nothing but the derivative of the function is existing or not, we are checking. So f of x is this one, evaluate f dash. Here this is having x, this is also having x, apply UV formula. f dash of x is equal x minus a whole power m into derivative of this one n into x minus b. U into v dash plus u dash v. U dash means x minus a whole power m derivative m into x minus a whole power m minus 1 into x minus b whole power n. So the derivative is existing, therefore f is differentiable. F is differentiable in open interval a comma b. Now coming to the third point. What is the third point? F of a is equal f of b. Substitute x as a in this one. In place of x write a minus a, 0. 0 into anything, 0. F of b is equal. Substitute x as b. b minus b, 0. 0 into anything, 0. Therefore, f of a is equal f of b. Three conditions. First one continuous, second one differentiable, third one f of a is equal f of b. Therefore, by Rolle's theorem, there exists an element C belongs to open interval a comma b such that f dash of c is equal 0. Here we need to verify Rolle's theorem. That means the C element belongs to open interval a comma b. This one we need to prove. F dash of c is equal to 0 implies replace x as c in this function, then we are getting f dash of c. Then this one c minus a whole power m into n into c minus b plus m into c minus a whole power m minus 1 into c minus b whole power n. Value is equal 0. That implies, take out the common term. In this one, common one is c minus a whole power m minus 1. And here c minus b whole power n minus 1. Then the remaining one is n into c minus b plus, here this one is, f dash of c is equal to 0 implies replace x as c. F dash of c means c minus a whole power m into n into c minus b whole power n minus 1 plus m into c minus a whole power m minus 1 c minus b whole power n is equal to 0. These two terms having common c minus a whole power m minus 1 c minus b whole power n minus 1. Then the remaining one is here n into c minus a, here m into c minus b is equal to 0. Now bring this term into the right hand side. 0 by anything value becomes as 0. That implies the remaining one is n into c minus a plus m into c minus b is equal to 0. This implies multiply n inside, nc minus an plus mc minus mb is equal to 0. This one and this one having c, take out common c. C into n plus m is equal, minus mb comes to this side plus mb, minus an comes to this side plus na. That implies c is equal mb plus na by m plus n. And here this interval is a comma b. M is to n ratio dividing point mx2 plus nx1 by m plus n always lies inside the interval. What is that interval? A comma b. Therefore, C belongs to open interval a comma b. Rolle's theorem is verified. Now we are going with another problem. Verify Rolle's theorem for f of x is equal log of x square plus ab by x into a plus b in closed interval a comma b. Here also Rolle's theorem we are applying for this. For Rolle's theorem we need three conditions: continuity, differentiable, and f of a is equal f of b. Given function f of x is equal log of x square plus ab by x into a plus b. This one can be written as log of a by b can be written as log A minus log B. This is equal log of x square plus AB minus log AB can be written as log A plus log B, plus into minus minus. So this is our function f of x, and here 0 less than a less than b less than 1. That means a comma b values are always lies between 0 and 1. And that's why this logarithm cannot become as 0, because of that log 1 is 0. So this one cannot become 0, this one cannot become 0, this one cannot become 0. So the values of that one are existing. Therefore, first condition f of x is continuous. Because of that, all logarithms are defined in closed interval a comma b. Second one, evaluate the derivative of this one. F dash of x is equal logarithm derivative 1 by x, again x square plus ab derivative 2x, log x derivative 1 by x. It is constant derivative 0. So derivative of the function existed as 2x by x square plus ab minus 1 by x. Derivative existed means f is differentiable in open interval a comma b. Now third condition, f of a is equal to f of b or not. Substitute x as a in that one. F of a is equal log of a square plus ab by a into a plus b. A square plus ab log of a square plus ab by multiply a inside a square plus ab. A square plus ab getting cancelled, log 1. Log 1 value is 0. Similarly, f of b is equal log of b square plus ab by b into a plus b. This is equal log of b square plus ab by ab plus b square. Both are same. So both are getting cancelled, log 1 0. So third condition, f of a is equal f of b. Two values are same. So third condition satisfied. So first condition continuity, second condition differentiable, third condition f of a is equal to f of b. Therefore, by Rolle's theorem, there exists C belongs to open interval a comma b such that f dash of c is equal 0. F dash of c. So here this is our f dash of x. Replace x as c in that one. Then this one 2c by c square plus ab minus 1 by c is equal to 0. Take LCM for this. Then this one c into c square plus ab. This one is 2c square minus c square plus ab is equal to 0. That implies 2c square minus c square minus ab is equal to 0. Denominator goes to right hand side, it becomes as 0. 2c square minus c square is c square minus ab is equal to 0, c square is equal to ab, so c is equal root ab, which is nothing but the geometric mean of a and b. We know that the geometric mean is always lies between the elements a comma b. Therefore c belongs to open interval a comma b. Therefore Rolle's theorem is verified. Thank you.